All right. Thank you very much, Andrew. Good morning and good afternoon to everyone. We appreciate your time today, and thank you for joining us for the StorTrends Virtual Lunch and Learn. Today we're going to talk a little bit about all-flash storage. We're going to talk about hybrid storage, and we're going to compare those to spinning disk storage. And we'll go into detail of each of those as we kind of just move through the presentation. We're going to show you a presentation for about 30 minutes today, and then we're going to switch over into an actual demo of an all-flash array. We're going to point out some of the features and functionalities of all-flash arrays and the benefits that they bring to the table over hybrid arrays and spinning disk arrays. And then we'll also talk about the pricing of all three. We're going to compare them. We're going to get into the details of kind of like the configurations and the price points, the advantages, the benefits. That way you just get a good feel for what all-flash storage brings to the table compared to the hybrid storage and the spinning disk storage arrays, which have been around for a really long time. So just a quick agenda here. We're going to go through an introduction to AMI. We're going to talk a little bit about our StorTrends product line and how it was developed and where it came from. We're going to talk about the storage landscape and kind of the changes that are coming to the landscape. Then we'll get into the comparisons of the all-flash versus the hybrid versus the spinning disk. We'll do a really quick StorTrends technology introduction. We'll talk a little bit about our support programs that we offer for our all-flash hybrid and spinning disk arrays. And then we'll move into that live technical demo. We're going to be showing a StorTrends 2610 all-flash array as our presentation today, after our presentation today. And we'll jump in and let you guys see and feel and touch that array so that you kind of understand what it looks like and the benefits behind it. We're going to also do a summary and QA session at the end. We'll try to answer questions throughout the presentation. So if you have a question, feel free to throw that question into the Q&A chat or into the chat itself, and we'll be glad to answer that question live if we can get to it. We've already got a little over 100 questions that came in during registration. We've sorted those, picked some of what we felt were the more pertinent questions that multiple attendees have asked repeatedly. So we'll get to those as well. But again, if you have questions, feel free to shoot those over in Q&A or feel free to shoot those over in chat, and Andrew or myself will get to those questions as we can. All right, well, let's get started. So just a real quick introduction to American Megatrends Incorporated, better known in the computer industry as AMI. You have probably heard of us. You've probably used us. There's a very high chance you've used one of our products in the past with being in an IT role. The corporate overview here, AMI was founded in 1985. We're based out of Atlanta, Georgia. We have a worldwide presence with 11 offices internationally. We've got a little over 1,400 employees. About 80% of those employees contribute from an engineering perspective. So we are a very heavily engineered-based company, and you can see that with the patents as you move down into the innovative IP section there on the screen. We have over 375 issued company patents. We've got more than 800 patents that have been filed. 128 of those granted patents are solely based off of storage and the StorTrends product line, and some of the features that we'll talk about today, such as deduplication, compression, thin provisioning, snapshots, and whatnot. So we'll move into the details of those patents and talk a little bit about that as we move into some of the technology talking points in the presentation. So from a worldwide recognition perspective, our products ship in more than half of the computers in the world today. There's a very good chance that the computer you're using to view this presentation on today has an American Megatrends product in it. I'm going to show you some of those products on an introduction slide here in just a second, and it'll probably jog your memory. We have shipped billions of products, and our mission statement is providing our customers the highest quality products the first time and every time. So, do you know AMI? Most people know us from the AMI BIOS. There's about a 70% chance that if you reboot the computer that you're using right now, you will see the American Megatrends logo like it looks in the black box on the screen here. That's the system level BIOS that's on that motherboard. We're in desktops, embedded systems, thin clients, notebooks, laptops, servers, even storage arrays. If you guys and gals are running EMC, NetApp, you kind of pick your flavor of a storage array. It's going to have an AMI BIOS on it. So there's millions of these shipped every year on PCs throughout the world. It's the #1 BIOS in the market today. The BIOS that we use today is called Aptio. That's its product name. The next product that you might not know about us, but it's definitely in your servers today, is going to be what we call the MG backplane controller. Back in 2009, AMI designed and developed the MG backplane controller. This is shipped by all the Tier 1 server motherboard manufacturers worldwide. This is what pushes the LEDs lights on the very beginning of the server, at the very front of the server. So you see the blue lights, the green lights, the blinking lights, the red light when something's failed. There's a lot of different specifications that each OEMs have where we customize that code to match their blinking pattern or blinking style or flashing style. This is what we also use for sensor control to control the SAS, SATA, and NVMe drives in the system. So every server has a backplane controller in it that's shipped, and we are the #1 backplane controller in the world. The next piece that you may not know us from, but we're there as well, is the Mega Rack piece. This is our remote management aspect. We're the market leader in remote management as well. This is your IPMI, your remote KVM, and your virtual USB. We designed and developed this back in 1997 as a Mega Rack G card. In 1998, Dell picked this up, and it became known as the DRAC card. So for those of you that are using Dell servers today, the R-Series servers, you're going to use the iDRAC card that's in there to manage that server remotely. Again, that's your remote IPMI, that's your remote KVM, and your virtual USB. You're using that to manage that server from a remote location. If you're using an IBM server, it's the RSA card. If you're using Sun, it's going to be their iPerk. If you're using HP, it's ILO. If it's Supermicro, it's SuperDoctor. You can kind of pick the OEM. The flavor of their card or their design has been modified for them. The Mega Rack technology is deployed as a software today. We moved away from the actual plug-in card. That moved into a single chip architecture, what we call a SoC, a system on a chip, back in about 2009. So today it's software technology that we provide to those OEMs, and then they in turn incorporate that into their server for remote management capabilities. So another product that'll jog your memory, this was the Mega Raid card. This was our storage entry into the storage market. So in 1994, we designed what's called the Mega Raid card or RAID controller. You can see 3 versions of it sitting here on the screen. It became the #1 RAID controller in the world in just one short year in 1995. This card was picked up by HP, it was picked up by Dell. At that time, it was picked up by Gateway, Fujitsu, Siemens, NEC. Just everybody that was making servers with the exception of IBM. IBM owned Milex at the time, so they chose to use their own dog food on their servers. But this card had about an 80% win rate across all of the OEM shipments, so it was the #1 RAID card in the world. Gartner recognized AMI as the RAID leader in the Magic Quadrant for 6 straight years. We sold this RAID division off to LSI Logic in 2001. When the market started moving away from a card and actually to an ASIC. So today, if you're deploying an HP server or a Dell server, again, just kind of pick your flavor of your OEM server, it's going to have a RAID controller on that server. The RAID controller most likely on that server is a Mega Raid controller by LSI Logic, which is now an Avago/Broadcom company. So you're still using AMI products in your servers today within your IT infrastructure. And now let's talk about the StorTrends introduction, the StorTrends product line. StorTrends was created in 2004. We came out with a dual controller 3400 in 2007. We migrated to a dual controller hybrid array in 2012, which added 4 to 6 SSDs to a mixture of HDDs in the box. 2015, we launched the StorTrends 3610, which is a 16-bay all-flash array. And in 2016, we're launching the 2610, which is 24 SSDs and a 2U24-bay array. So this is kind of the data storage evolution. If you look at any other roadmap out there from EMC, NetApp, kind of you name it, we were all spinning disk in the 90s to early 2000s. We migrated into the hybrid arrays in 2011 to 2013. And then 2013, 14, 15, the all-flash arrays started to come out, and now there's a lot of choices that are out there in 2016. I read an article the other day where there's over 70 vendors now that are offering all-flash arrays. So there's a lot of people that are in this market vying for that space for the all-flash customer. So let's take just a few seconds and talk some marketing points here. Let's talk about some of the end customers and the verticals that StorTrends has sold into and kind of where we specialize. StorTrends has thousands of systems deployed worldwide. So we've been shipping since 2005 with this product line. So you can imagine over the last 11 years, we have shipped thousands and thousands of storage arrays. These appliances have gone into all different types of verticals, from education, advanced research, financial, healthcare, manufacturing, high-tech, legal, retail, service providers, small enterprises, government, both public, state, federal, private sector. You kind of name it. There's not a specific niche that we fit into. Where our boxes fit is anyone looking for just a few terabytes up to a 500 terabyte realm is our sweet spot. Centralized storage, backup storage, disaster recovery storage. Those are our specialty points that we meet for any of these verticals. Just a real quick snapshot, just wanted to give a little collage here to kind of highlight some of the customers that we sell to. You'll notice that there is a logo here for every customer that represents all of those market niches that we just talked about, all of the verticals. You'll see education here in the colleges. You're going to see medical, the hospitals, the radiology clinics that are running our storage. You're going to see retail from Walgreens, PGA Superstore. You're going to see legal from Bender & Bender, government, Lockheed Martin. You kind of name the customer and we've got an install there. Again, with thousands and thousands of installs worldwide. And the focus, if you notice, for most of these customer logos that you see here is the SMB to the SME market. That's small to medium business and small to medium enterprise. We do not play in the enterprise market. We do not offer fiber channel in this box. So it's an iSCSI only solution, 1G or 10G with 40G on the fringe of being released. So we play in that small to medium business, small to medium enterprise area. All right, so let's take just a couple seconds here and let's talk about why you're here today. So why are you here? Most customers that come to our event, they're experiencing some type of high latency. This is in order of the attendance for most of our events, whether it's a lunch and learn, a webinar, a virtual lunch and learn. Most people tell us and give us feedback that they're having high latency in their current environment. They're starting to see applications run slow, or they're having users complain, applications timing out, VM timing out from either VMware or Hyper-V. They're starting to run into latency issues, and usually it's because they're trying to push too much data across the disk sets that are sitting in their current infrastructure today. They need to either move into a hybrid environment or an all-flash environment. And we'll talk about the solutions for some of these pain points in a couple more slides. The number two reason that most people come to our events is for a VDI project. They're looking to find a very safe and cost-effective way to create VDI. So does that mean I use VMware Horizon View? Do I use Citrix? How do I build it? What do I do with it? We get a lot of questions around VDI and how the SAN fits into the VDI environment and the configuration of that SAN that's needed. The third reason is a storage upgrade. People are running on older storage. They've got something that's kind of dated. It could be 5, 6, 7, 8 years old, and they need to upgrade in either 2016 or 2017. So they're starting to run out of capacity, which is the fourth bullet point, and they need to do something. So you're running out of the footprint that you've got, and you need to invest into more storage. Does that mean I need disk, spinning disk? Do I need a hybrid box, which gives me a little bit of performance and a lot of capacity? Or do I need to go for an all-flash? I'm hearing that all-flash is coming down in price. A lot of vendors run around saying flash is at the price of spinning disk. You probably get a proposal and then you go, yeah, this is nowhere close to spinning disk pricing. And we'll talk about some of that in a few slides. But the fourth reason that most people come to our events is capacity-based issues. The fifth would be a new build-out. They've got some kind of a new IT project. It may be a new application. It could be that your company has acquired someone or you're going to acquire someone and you need to make accommodations for more capacity, more storage, and you're starting to look at vendors. You're starting to kind of stick your toe in the water. What's out there? What are my options? What is the cost for these kind of things? And then the next item is learning and planning. You're really looking for something for either 2017 or beyond. You're just here today because you're wanting to find out about new technologies. The last bullet point, a lot of people show up for this, free pizza. You just want to stop by, have a free pizza, kind of enjoy the day. It's a great way to get a free lunch. If that's you, we understand you're here. We hope that we can at least pull you into the previous bullet point and we can help you learn something or maybe help you plan something in the future. All right, so a real quick level set here. We want to just kind of stop and pause and explain the differences from a 30,000-foot viewpoint of spinning disk, hybrid SAN, and all-flash SAN. There are three very different architectures. If you look at different vendors, the spinning disk SAN is pretty much the same across all the vendors. You know, I could put an EMC logo up there in that architecture slide. I could put a NetApp. It could be compellant. You could kind of pick who you want to put in there, and they would fit that architecture, you know, from an HDD SAN architecture perspective. But the hybrid SAN and the all-flash SAN, they differ greatly between vendors, and we'll talk about some of those going forward. So just to kind of level set when we're moving into the next few slides, let's first talk about the spinning disk SAN architecture and the overview of it. Spinning disk SANs were either a solid SAN with 7,200 RPM drives, or it could be a mixture of some kind of a 15K SAS, 10K SAS, and 7.2K SATA. Just depending on how much performance you actually needed, the SAS drives would throw around 300 ops per drive. The SATA drive or the NL SAS drive is going to throw around 150 ops per drive. So you would probably have a lot of these boxes kind of clung together if you're a larger company. If you're a smaller company, you may only have one of these. You may only have a single SAN, a single head sitting there with anywhere from 8 to 16, maybe even up to 32 terabytes of capacity. The most common architecture that we see is a spinning disk architecture with 15K SAS or 10K SAS on the top, and then 7.2K SATAs or 7.2K NL SASs sitting on the bottom. It kind of gives the auto-tiering effect. So back in 2007, auto-tiering became a very relevant piece for small, medium businesses and small to medium enterprises, where you could take data that was hot at one point in time, it had become cold, it wasn't touched, it was stale data, and it would get migrated automatically down into the lower level HDDs off of the more expensive SAS drives. If that data block was hit and you started touching that or accessing those regions or blocks again, we could promote that data back up. Most vendors did this auto-tiering architecture where you could move the data back and forth. So the 15K SAS drives are used to host the hot data. The 7.2K SATA drives were used to host the cold data. Now let's talk about the hybrid SAN. It's a little different. The hybrid SAN changed when the all-flash drives pricing became obtainable for SAN and storage vendors to really start using a small number of these drives inside of our footprint of the box. Most hybrid SAN architectures have either 4 or 6 SSDs in the front end, and then they'll have anywhere from 10 to 12 spinning disks in the back end. So it's a mixture of SSDs and HDDs. The SSDs are used to host the hot data. The HDDs are used to hold the cold data. So the hot data is in red, the cold data is in blue in the architecture picture here on the right side of the screen. Again, we would do the tiering between those two different types of drives. As the data became aged and became cold, we would move that data down into the spinning disk layer, and it would sit there. If it was touched or accessed so many times an hour or a day, you could take and move that data back up automatically into the SSD cache or the SSD tier. So there was a good way to move the data back and forth, but it did create some pain points, and we'll talk about some of those in the future, in the next few slides here, about how hybrids were really good, but if you didn't spec them properly, they could be really bad for your environment. Now let's move down into the all-flash SAN architecture. It's an architecture with all SSDs, and there's a multitude of different types of architectures that are out there. There's single tiers, there's split tiers, there's multi-cell tiers. They have different types of drives. Some vendors are using SLC, others are using MLC, some are using eMLC, which are enterprise MLC drives, whereas others are using TLC, consumer, or either client-grade SSDs. So there's a whole lot of different vendor architectures that are out there, but the overall overview of an all-flash SAN is just that it's all SSDs, so you get complete SSD performance. No longer HDDs in the mix here, so you're able to see anywhere from 12,000 up to 25,000 IOPS per SSD drive. So the SSDs are used to host both your hot data and your cold data. So I left them all red in this architecture picture just to kind of drive home the point that the data is basically all hot. Even though the data could be cold, it can be accessed as hot data. So just want to make sure everybody kind of understands that piece of it as we move forward.
Yeah, and we just had a quick question here coming in from Derek Carter asking if we could go into a little bit more detail explaining hot versus cold data and possibly some thresholds or examples of that.
Yeah, sure. Great question. So hot data is basically the data that your applications and your users are accessing at any point in time. Most of vendors look at hot data in a 1-week increment. so that way we know, kind of what's hot from a Sunday to a Sunday in your environment. Obviously, when you do backups, you're touching the data and you're reading it, but that's not hot data. Hot data is the data that's being written, rewritten from the applications and the users into the SAN array. So hot data could be a small portion of your overall capacity. Let's just say, for instance, that you've got 30 terabytes of usable capacity, used capacity in your array. You may only be using 1 terabyte of hot data, 2 terabytes, 3 terabytes. When the hybrid SAN architecture started coming out in 2012, most vendors, including EMC kind of leading that charge, were running around with a flag in the air saying 10%. 10% is your hot data, 90% is your cold data. What we found is that's not accurate at all. It just depends on your data set, your applications, and what your business is doing to generate those data points. A lot of our customers, we find, break that 10% mold. They're 14%, 17%, even upwards into 30% hot data, with the remaining being cold data. I'll talk about a tool in a few slides that's called StorTrends iData, and the purpose of that tool is for you to run it in your existing infrastructure today so that you know exactly how much hot data you have in your environment versus cold data. What it does is it installs and it runs for a 7-day period. So if you're using VMware, let's say you've got vCenter running, it plugs into vCenter and it allows you to manage and to see all of your virtual servers and all your physical servers sitting under vCenter. And then it watches the blocks of data for a 1-week period. It doesn't generate any I/O, it's just recording. And while it's watching these blocks of data, it's telling us the number of total writes coming in, the rewrites, and the hot reads coming into the box. That allows us to establish a base pattern for you of the amount of hot data you generated in that 1-week period, and then the remaining data that's cold in the environment. So at the end of that 7-day run, you'll have an exact number, and you'll know, okay, in my infrastructure, I'm 15% hot, I'm 85% cold. So that iData tool was created so that our customers would know how much hot data versus cold data so that we could spec the proper hybrid SAN architecture. So that's a great question. All right, so just kind of moving forward here, let's talk about the evolution of the StorTrends product model. So if you saw on the previous slide, 2 slides ago, I showed you a 3400 that came out in 2007. That's on the left side of the screen here in the product matrix. That's our spinning disk array. That's a 3U box with 16 drive bays. It can come with either SAS or NL-SAS SATA drives or a mixture of those. It can scale up to 256 terabytes. We do that by having a head, and then we can add 3 additional expansion chassis underneath it. It doesn't support deduping compression. It does support thin provisioning, snapshots, your standard storage functions and features, and that's a shipping platform. The next box is the StorTrends 3500. That's our hybrid array. Again, it's a 3U 16-bay chassis. It comes with either 2, 4, 6, or 8 SSDs in the front end, with the remaining back end of the box filled in with the NL-SAS drives. So you can have either 200, 400, 800, or 2 terabyte SSDs, which are all write-intensive SSDs. And in the back of that box, you can populate it with 1 terabyte, 2 terabyte, 3 terabyte, 4 terabyte, or 6 terabyte NL-SAS drives to give you a lot of capacity. So the 3500 was created to give customers the performance they needed, but at the same time to give them the same capacity that they were used to in that 3U appliance. Moving over to the right is the 3610 and the 2610. These are both of our all-flash array offerings. The 3610 is a 3U 16 drive bay box. It's the same chassis that our 3500 and 3400 were architected upon. The 3610 comes with either 200, 400, 800, 1.6 terabyte, or 2 terabyte SSDs in the write-intensive side of the box. And then in the read-intensive side of the box, it's going to come with either 240s, 480s, 960s, 1.6s, or 3.8 terabyte SSDs. Again, it expands to 256 terabytes. It's a head plus 3 shelves. This box does support deduplication and compression, so we can squeeze more data into that appliance than we could with the 3500. The 2610 is our new offering. It's going to be released here next month, at the end of the month on Halloween. This is a 2U 24-bay box. We've basically taken the same technology in the 3610 and we just pushed it into a 2U form factor. A lot of our customers were asking for a denser solution. They were wanting to get closer to 200 terabytes in just a 2U form factor, so we were able to do that for them, and we're creating this 2U 24 drive bay box. Again, same drive options as the 3610 for the write-intensive, same options for the read-intensive, same capacity expansion support, same capacity expansion through the shelves, and it also supports deduplication and compression. All right, so let's talk a little bit about performance. We get this a lot. You know, a lot of customers come to us and say, hey, I'm running 3 Dell EqualLogic boxes. They've been meeting my performance requirements. They're just aged. They're going on 6 years old, and I need to do something. What do I need? Do I need spinning disks? Do I need a hybrid box? Do I need all flash? Kind of where am I at? Help point me in the right direction. It really depends on what you need from an application perspective from a latency standpoint. You know, if you're using a spinning disk solution like we just referenced, a Dell EqualLogic box, that box is going to have either 16 or 24 HDDs in it. You're going to get anywhere from a couple thousand IOPS up to about 5,400 IOPS in that box, that single unit. And it just really depends on the drive configuration that you've got. But that's one of the things that the iData tool is going to do as well. It'll allow you to install it, and you can get a total for your IOP count across all of your boxes, and it can tell us your total latency build that you're looking at today as well. So we can come back to you and say, okay, your total latency today is around 20 milliseconds. With a hybrid box, we're going to be able to drop you into a 5 to 10 millisecond realm. With an all-flash box, we're going to be able to get you down into a 1 millisecond realm. So really, how fast do you need the performance? Are you okay today? Are you starting to struggle? Are you starting to see latency timeouts or your users complaining? If so, let's tighten that up and getting you into a box that's going to allow you to have a lot less latency and improve your performance. So this slide compares the 3 offerings from AMI, the spinning disk solution, the hybrid solution, and the all-flash. We did this at an 8K block level. We split this up in a pretty random workload of 70% reads, 30% writes. This is just an average latency chart. The tool that we use here to run this against is the VMware vMark. So this simulates the user environment from a VMware perspective. And it adds the queue depth as you move from left to right with the number of threads as it increases. This is called their tile test, and you pass each tile as you move forward, and then it shows what the latency is doing as it's adding load to the box. So the red line in the very top here is a 3400. These are going to be our NL SAS drives that are in this box. So you can kind of see it starts out in the 18 millisecond realm, and it kind of averages in that 20 millisecond realm as it moves forward. You're going to see these spikes, and you're going to see these wanes as it goes through kind of an up and down yo-yo approach. That's very typical of a storage array, especially in this kind of a test with VMware, because what it's doing is it's loading up the advanced cache, which will be our system RAM in that 3400. It's having to flush the data to disk, commit it to disk, and then wait. So the queue depth's filling up, and then it's flushing. So you kind of get this yo-yo approach as the performance is up and down, up and down, up and down as it's moving through the tiles. But you can see that box successfully holds at around 20 milliseconds of average latency. The 3500, in this configuration, it had 4 SSDs in the front end and 12 spinning disks in the background. You can see how much lower we were able to bring the latency down into this test scenario with those 4 SSDs. So we went from an average of around 20 milliseconds down into an average of what I would call about 6 to 7 millisecond realm. It brought the load greatly down. Now, you will notice the green line, it actually improves. The lower latency, the better in this test, so it's kind of like golf. You'll notice that it kind of starts off a little high and then it starts moving down. The reason for that is our hybrid array has both caching and tiering built into the box. Most hybrid arrays have either or. They'll have either a large cache or they'll have a large SSD tier. There's only 2 vendors out there today that have both caching and tiering in their array. Now, what the caching for us does, when the tier fills up, so as it went through this VMark test and the tier filled up through so many threads, after the tier got full and about the 4 thread count towards the 8 thread count, we started using the cache as a parachute for the tier. So the data, the incoming I/O load gets diverted from the tier because it's full into the cache. And then once the tier purges downstream to the spinning disk, it makes available room. I/O writes can then start going back to the tier. So we use both caching and tiering to leverage one another to keep that performance down. So you can see with the 3500, it's kind of unique. As you load the box and the load becomes heavier, the performance actually becomes more consistent and it becomes more flatlined. So that's the reason that you see that kind of fall off with that hybrid array. If it was a different vendor in here, like a Dell Equalogic box, or you just kind of pick whoever your hybrid array is, if they only have caching or tiering, you're going to see that line kind of stay in that 10 to 15 millisecond realm. You'll never see it come down into the sub 5 millisecond realm under this test load. And then the blue line at the very bottom is our all-flash array. This is a 16-disc, 3610 array. You're going to see that this is a sustained performance somewhere around 1 to 2 milliseconds. This is a large load that this is generating on this box, but the average latency keeps it just right around that 1 millisecond realm. So that's kind of the difference between your spinning disk, your hybrid array, and your all-flash from a performance aspect. So let's talk just a few minutes about pricing. Most of our customers are really interested in this slide. This is kind of what they want to see. They want to understand, what's the price point? What's this going to cost me? I noticed there was a slide that just came in, a question that just came in a minute ago. We've got a bunch of questions on this. You know, Tim asked this question when he registered from Oregon. Why is flash storage still so expensive? Mary just chimed in through Q&A here, or actually private chat, wanting to know how much the all-flash costs compared to spinning disk. That's a very frequented question that we get from our end customers. So we like to line all three of our boxes up and just kind of show you what they would cost you if you pulled the trigger today. On the left here, you're going to see the 3400. This is a spinning disk solution. Now, the usability capacity perspective that we tried to hit with this was 50 terabytes. So we're a little high on the terabyte capacity for the 3400, but that's the only configuration that we could offer that could get you close to the exact 50 terabytes. You'll see it started with 73.6. After RAID, after the operating system, the usable capacity came down to 58.57. You can see that the latency is somewhere around 10 to 15 milliseconds. The IOPS are going to be about 4,800 IOPS that it's going to generate. It's a 6U form factor. We had to put a SAS head with an NL SAS expansion shelf underneath it. So it's two 3U boxes that make up the 6U. It's roughly 6,100 kilowatts per year in power, and it generates about 6.1 tons of CO2 emissions. The list price is $59,058. The street price today that you could buy this from CDW, Zones, SHI, Insight, your local reseller, you name who you want to buy it from, it would cost you $29,782. So if we take $29,782 and divide it by the usable capacity of 58.57, we get 49 cents a gig. That's pretty common for a spinning disk solution that has a little bit of performance in it. A lot of our configurations are in that 40 cents range for that 3400. Now into the middle box, into the silver box here, is the 3500i. This is our hybrid array. It's a 3U 16-bay array. We start off with a raw capacity of 73.6. The usable capacity after RAID and the OS swipe is going to be about 49.48. The SSD space in this box is 5.82 terabytes. The HDD space in this box is 43.66 terabytes. It's going to give you a latency mark somewhere around 3 milliseconds, but it is going to generate about 200,000 IOPS. So the IOPS go way up. The latency comes down to about 3 milliseconds. It's a 3U box. It's got 5,028 kilowatts per year of power, and it's going to put off about 3.5 tons of CO2 emissions. The list price is $106,999. The street price is $31,920. If you take $31,920 and divide it by the usable capacity of 49.48, it comes out to 63 cents a gig. So it is about 14 cents per gig higher than spinning disk. Now let's take a look at the green box. This is a 2610. This is a 2U 24-bay all-flash array. We start off with 28.64 terabytes. The usable capacity is 52.28. Now, how does my usable capacity increase? It's because of the deduplication and the compression. So you'll see that we do not perform dedupe or compression in the 3500 or the 3400. The reason being is it taxes the resources way too hard in the system. Your latency would go way up, your IOPS would come way down. If I take and turn my deduplication and compression off in this 2610, the 250,000 IOPS that you see there in the middle of the screen, it would actually be 1.2 million IOPS. So that kind of gives you an understanding of how hard deduplication and compression are on the system from the CPU perspective, from the system RAM perspective. But fortunately, we have enough SSDs in this box. We have 24 SSDs. It allows us to use those technologies and take that performance penalty and still deliver high performance. We can still stay at 1 milliseconds latency and around 250,000 IOPS. The deduplication ratio that we use today is a 3.3 to 1. The compression ratio is a 0.7 to 1. Most of our usability cases that we see from our end customers, if they're in a virtualized environment, that means if they're running VMware or if they're running Hyper-V or if they're running Citrix on their servers and they're in a virtualized infrastructure, they're going to see around a 4 to 1. So what does that mean? That means we can take a 1 terabyte drive and we can put 4 terabytes of data onto that 1 terabyte drive. It's a 4 to 1 ratio. Now, the SSD hot data in this configuration is 10.37 terabytes. The SSD cold data capacity is 41.91. But I do want to call out that the entire 52.28 terabytes is all flash. This is an all flash solution. So 1 millisecond latency, 250,000 IOPS, it's 2U of rack space. It's only generating 3,302 kilowatts per year in the power. That's because it's using all SSDs. There's no mechanical disk inside of this box, so it uses less power, which means it's going to have less emissions as well. It only generates about 2.3 tons of CO2 emissions, so it's a lot greener solution as well. List price, $106,999. Street price is $33,962. If you take the street price and divide it by the usability capacity of 52.28, you get 63 cents a gig. So you can kind of see here by looking at these charts, hybrid arrays and all-flash arrays are really competitive now. You're getting into a scenario where they're just about the same from all vendors. Some vendors are still charging a lot for their all-flash arrays. They still try to charge a premium for an all-flash array. Other vendors that have been in the market a lot longer, you'll see that, we kind of got the technologies to where they're side by side, especially using deduplication and compression. It allows us to get the price way down. But they're still not where spinning disk solutions are. So if vendors are telling you, I've got an all-flash array, it's the same price of spinning disk, that might be true 5 years ago, but it's not true today. The price of disk continues to decrease just like SSDs. There's always going to be some type of a delta there, but you can see here that that delta is getting a lot closer. All right, so if you're sitting here looking at this and you say, okay, I don't need 50 terabytes, I need 200 terabytes, or maybe I only need 2 terabytes, do you have a configuration for me? The answer is yes. We have over 300 configurations available. We also have an online price quote generator. You can find that at StorTrends.com. So if you want a price quote on a specific configuration, if you'll go there, it's going to ask you for some inputs of specific values. You need to know your capacity. You need to know what your IOP range is. You're going to need to know the interface type. It would be preferable if you know the read-to-write ratio. There is some functionality there that will help you select the right one. The application type, and then we need to know the support level and the support term. Once you fill those pieces out, it's going to generate a price quote for you and email that to you so that you can get an understanding of what it looks like from a budgetary perspective for one of our arrays. All right, so let's quickly move into the StorTrends technology slides, and then we'll jump into the demo. Just want to point out some of the key features and the major features within the StorTrends product line. If you look over to the right, our operating system is called StorTrends ITX. Some of the features that surround that, deduplication, compression, advanced snapshots, thin provisioning, in-lift cache, replication, auto data tiering, and then we have our own RAID called RAID RT. And I'll talk about some of these as I move through the demo in just a few minutes. Again, just want to point out that this is an all-inclusive feature set. There's no single price points for certain features. Once you purchase the product, you get all of the features completely enabled, and you decide if you want to use those or not. The main target that we hit for our customers, the applications, they're using us for high-performance databases. They're using us for mixed workloads, virtual desktop infrastructure, VDI, and then also virtualized environments. All right, this is an eye chart, and I'm not going to walk through it, but this slide deck will be provided to you. It'll be emailed to you, so you can kind of take a look at some of the enterprise-class features that come baked into this product. Just want to call out here that we are VMware, we're Microsoft, and we're Citrix certified for all of our platforms. So no matter the hypervisor, we're even KVM certified if you're using KVM as your hypervisor. All right, so let's talk just a few seconds about a couple technology slides. We're going to talk about StorTrends deduping compression first. A lot of our customers, they really like deduping compression. A lot of our customers are nervous about it, and some just straight up don't want to use it. They don't trust it. They don't think that they'll get any type of a deduping compression savings based off of the databases and the applications that they're running. So deduping compression has been around for 20-plus years. Most of you are probably using it in your backup environment today. Your backup softwares or agents, back to DR, whatever you're using there. You know, if you're still on old tape, if you're that old on it, it's going to be using a dedupe and a compression technology. So this isn't anything new that all of these all-flash vendors have created. But we couldn't use dedupe and compression on spinning disk storage arrays because of the amount of system memory and RAM that were chewed up. There wasn't enough IOP performance either from the disk. So the disk would starve IOPS, they would time out, the CPUs weren't large enough, the memory wasn't large enough in the platform, the footprint of memory to be able to run the dedupe and compression on the inline data. So it was avoided. Now that we have, 10, 12, 16 core CPUs, we have, anywhere from 200 to, all the way up to 1.5 terabytes of system RAM inside of these boxes. We can use these technologies now in line. So we use deduplication and compression. Just want to go to the bottom of the slide here and talk about some of our patents. There's 6 granted U.S. patents on dedupe and compression. Some of the competitors that we compete against, they don't even have 6 patents for their entire product line. So we really pride ourselves in creating the best-of-breed technology. We patent it, and then we bring it to the market. So the deduplication and compression engine that's in this box is phenomenal. Most of our customers see a 4-to-1 data compaction ratio. Now, data compaction means dedupe and compression combined together. So an example would be a customer needing 40 terabytes of capacity. They can purchase 10 terabytes of physical capacity, and they can move 40 terabytes of data onto that 10 terabytes of capacity. Even with high performance, even if you still need, let's say you need 120,000 IOPS, we can do that with this deduplication and compression turned on and still provide sub 1 millisecond latency. Now, in this box, we have a mixed tier. We have an all-flash tier for our hots and an all-flash tier for our colds. We call it a WT and an RT. WT is the write tier. RT is the read tier. So it's not a hot and cold mix anymore. I've got hot and cold here because that's the way most customers know it. But it's really a write versus a read break. So once a write comes into the box and that write becomes cold, we'll move that write into the actual cold tier. So you can see how our data compaction works. The hot tier fills up. As the hot tier is starting to fill, we'll move that data based off of policies that you set. They come auto-set, and then you can migrate those policies and manage those policies to pull it down or increase it as far as the data compaction goes. And then it's squeezed down into the cold tier. So it's deduped and compressed from that perspective. All right, so StorTrends in-lift cache. This is another highly patented technology that we have in StorTrends. This resides on our enterprise MLC drives in the box. This thing does 2 things. First, it provides extreme performance. So when you take a look at what you're going to see from an IOP perspective and a standard load on this box, you're going to see around 231,000 IOPS. That's with dedupe and compression turned on. They do generate latency. Most of the time they bog the SAN and they'll create queue depth issues. But in-lift cache is what's known as the performance buffer. So if you look at the right side over here, what happens is when a write comes in, it goes into the write tier, then it's moved into the read, and then the read comes out. The question is, what happens if a rewrite comes in? So if you look to the screen on the image on the far right, the rewrite comes in as block Z. Instead of sending block Z down to the read and bogging the SAN, we actually send it into our in-lift cache. So it's a swipe that we carve out on our EMLC drives. It's where we dock those writes, and then we'll migrate those at one time downstream during the day when the system is idle. So we pick the time when we're going to move it. That allows us to really keep the performance high at all points in time during the day when you're utilizing the system. It also allows us to protect the endurance of the read tier drives. So the read tier drives could become burned out if we're continuously reading and writing from them. So when we have a rewrite that comes in for a block that's in the read tier, we'll move that in in-lift cache, and then we'll do one consolidated write one time a day downstream to the read tier. This is how we guarantee a 5-year endurance guarantee on our storage boxes. All right, so final question here before we move into support and then jump into the demo. What's the best option for me? This is where a lot of our customers start. I want all flash, but I'm not sure I can afford it, but do I really need a hybrid? or should I just stay with an HDD array and with what I've got now? It really depends on your data compaction. What's your data compaction ratio? A 3-to-1 or higher is very ideal for all-flash array candidates. So if you can obtain a 3-to-1 or higher, all-flash is going to make more sense from a dollar and cents perspective than hybrid or HDD arrays. If you're less than a 3-to-1, you probably should look at a hybrid SAN architecture. But the key is you need to know what your hot data is, and that's the slide that we just landed on now. This is the StorTrends iData tool that I talked about in the beginning of the presentation. This is downloadable for StorTrends.com. It's free to run. It sets up in just a few minutes. You can run this on physical servers if you're not yet virtualized. You can run this inside of your virtualized environment. If you're running vCenter, this plugs in underneath vCenter, and it allows you to easily see all of the devices underneath it. It's going to go out and do a server discovery. You're going to select which servers you want it to manage and actually monitor for that 1-week period. And then you can see the screen on the right is what it's going to output. It's going to give you an overall summary. It's going to give you a breakdown of each VM. It's going to give you a breakdown of each physical server. And then it's going to give you a complete summary of the whole environment. It's going to tell you the number of CPU cores, the processors, the CPU, the memory. It's going to tell you what your IOPS look like. It's going to tell you how much capacity you're using, your read-write ratio. But outside of all of that, all of those are really good things. Even the network, the CPU memory utilization, the throughput. The key thing is it's going to identify your hot data and your cold data. That way you know exactly how much hot or active data is in your environment during that 7-day run. That's going to allow you to spec properly for your next storage array. So we have all of our customers run this tool, and that way they know exactly what's happening in their infrastructure before we even start talking about a product model or a product configuration. All right, so just real quick, and then we're wrapping up with the presentation. StorTrends support, the storage experience, something that we do a little different. We do not hire help desk technicians or help desk support reps. We hire StorTrends engineers. They're storage engineers. This is guys and gals that have computer science degrees, electrical engineering degrees. They are going to resolve your problem when you call in. When we receive reviews from all of our customers, when we send them a customer review asking them to fill out, support always receives a 10 out of a 10. And it's something we really pride ourselves on because we know that if we take care of you and we take care of our product, you're going to become a repeat customer for us in the future and help us grow this product and grow with the company. So we really pride ourselves on support. We offer both 4-hour and next business day on-site support, no downtime maintenance, and we can do scheduled upgrade assistance with our support engineers. We do proactive health monitoring through our Store Vitals cloud, where we're actually monitoring all the alerts on your array, and I'll show you that in just a few minutes in the demo. And then we guarantee our SSDs for 5 years. The support terms are from 1 to 5 years. All right, so let's jump into the demo really quick. I think it's going to time out on me here. Nope, we're still in. All right, so when you log into the demo, this is what we call Manage Trends. This is our management GUI. This allows us to manage this device, and you can see at the top of the screen you can manage any other device that's in the same subnet. So if you have another StorTrends SAN, if you're an existing StorTrends customer, you add the 2610, you can simply jump up here to your other SAN, click on it, and you're automatically in that box. You don't have to jump through screen after screen after screen to try to get to different boxes, so they can all be managed from one local point of view. The first thing you're going to notice when you log in is this is the storage statistics for the box. So this is telling us everything from the overall storage pool perspective. We can jump into the volumes tab here in just a second, but I just want to explain what you see from the overall storage pool perspective. The physical capacity of this box is 6.02 terabytes. The predicted capacity is 22.51. So how did we get that? Well, we put 690 gigs of space. I migrated 690 gigs of data onto this array, and it squeezed it down to 184.64 gigabytes of used space. So there's my calculation. That's how I've gone from 6.02 terabytes to a predicted 22.51. That throws a data reduction rate of 3.7x. So this would be a 3.7 to 1 data reduction ratio. Now it also tells me my predicted free space of 21.83 and my physical free space of 5.84. You'll notice here if there's any type of an alert, it's going to come up right here in the main home screen for you to see. So if power supply fails, in the event that you're running out of space in one of your volumes and you need to expand a volume, you're going to get an event or an alert here. You'll notice that we keep some of our SMART statistics here. We tell you that the SMART health of each of the drives is normal and it's good, and then we tell you that the temperature status of the drives is good. So we watch the two important factors within the drives to ensure that they stay healthy. Now, as we move down, you're going to notice we have a performance charts. We have latency, IOPS, and throughput. You're going to see that this is both instantaneous, which is real time, which refreshes every 5 seconds, and then you're also going to notice that there's an hourly average here. So the blue is going to be my read latency, the green is going to be my write latency. So you'll see that overall average, I'm averaging somewhere a little around 1 millisecond of total latency if you average the two together. My reads are around 1.58 instantaneous, whereas my writes are around 50.55. You'll see that the IOPS, this box is really full right now. I'm running a FIFO script on this box that's showing a lot of different changes to the box. So I'm pushing somewhere around 75,000 IOPS in this box right now. You can see I've kind of used, it's 55,000 on my reads and 23,000 on my writes, which gives me a total of 78. And then you see your throughput. I'm pushing about 215 megabytes per second of reads, and I'm having about 92 megabytes per second of writes. So you see that carves up my read and write ratio down here at the bottom. I'm 70% reads and 30% writes. And then everything that I'm doing right now is at the 4K layer. So everything I'm running through IOmeter right now is at a 4K. So this kind of gives you an overall viewpoint of what's going on in the storage pool. Now, when you jump into the actual volumes, you're going to notice that you see all of the volumes in the box here showing up in this chart. So it's going to tell me how much I've got mapped. It's going to tell me how much my snapshots. I don't have snapshots set up, but if snapshots were set up and it was taking snapshots, it would show me how much is consumed versus how much out of the mapped. Now, when we move into the volumes, you can select different volumes. As you change the volumes, you'll see the charts below change. So this is something really good that gives me an understanding of what's going on within my infrastructure per volume base. You can also grab the graph and you can pull the graph and you can actually see the data within the graph from a point-and-click perspective. And again, same latency, same IOPS, same throughput chart. It's showing it based off of the volume now, and I'm seeing this off of volume high 1. And then I also get a carved-up ratio of my reads versus my writes and then what my ratio looks like. All right, so now that we've seen this from the storage perspective, we've seen this, the storage pool perspective, we've seen it from the volume perspective, let's move into something that's kind of cool, which is our hardware health. Basically, this is where you go anytime you have some type of an alert pop up in the box. This is a 3D representation of the array. It shows the front. You can see that these are the different types of drives. When you hover over the drive, it's going to tell you the statistics of the drive, the serial number, the total space, tell you what pool it's in. If it's online, it's going to tell you if it has any issues. If you want to reverse the back view of the box, you just hit the reverse button. You notice I pulled a power supply out before we started. So I wanted to be able to show what it would look like if the power supply was bad. So I just pulled the cord out of it to make it like it had a fault. But you'll notice the machine's still up and operational. So how is that? Well, what happens is this box is only required to run off of one power supply. So one power supply can run both controllers. So it's 1 plus N. The other power supply is up and it's still good. But you'll see your errors are having little X's over them with little red bangs. Everything that's good is going to show a green check. So again, it's just a good visual representation of the box to kind of understand what's going on inside of the array. Let's move on down really quick. I know we're pushing time. We need to be ending for questions here. Software health, this comes in and tells you a little bit about what's going on in the box from a health perspective. Management console, we can log into CLI. We give you root access to the CLI. So if there's any type of scripting or anything that you want to do, if there's something custom that you need done to the box, we can absolutely do it. Dashboard, this is where you set everything up in the array. This is where you manage the array. Your hardware health, you can set up an SNMP trap. You can add a firewall. This is where you would add anything if you need to update your license. From a control perspective, you can push the controllers on and off one at a time. UPS support, we support both local and network-based UPSs. This is where you would update the box. It's a one-click update off of an FTP. This is where you would set your date and time and sync your controllers. This is the debug dump. So in the event at 2 a.m. in the morning, you have some type of an issue, you can go into the debug dump, hit the debug dump button. It's going to automatically generate a debug dump, load it to our StorVitals cloud, and then we'll take a look at it and let you know what's going on in the box. So it's a really simple process to kind of manage this box. All right, so I'm getting the warning here from Andrew that we need to wrap up. I'm sorry we didn't get through all of the demo. If you do want to see an extended version of the demo, we can set you up with one of our solutions engineers. If you will just email Tyler Newberry at tylern@ami.com. He's the one that set up the webinar today, so you should have his email address. I'll flash it here at the end of the screen in just a second. But if you can contact either Tyler or Andrew, they'll be glad to put you with one of my solutions engineers and set you up with an individual demo so that you can really go through the demo line by line, kind of understand what's going on completely from head to toe with the product. So with that, I'll turn this over to Andrew.
Thanks, Justin. And I'd like to go ahead and also thank everyone who's been asking questions while we've been going through this. We are answering these to the best of our ability right now. So if we haven't gotten back to you already, you can rest assured that we will answer your question as soon as we can. That being said, I'd like to go ahead and turn things over to answering some of the questions that you all asked upon registering for the event. First one I have here is from Philip in Tennessee. How many SSDs are populated in the 2610 all-flash array?
Okay, that's a great question, Philip. There's 24 SSDs in the array. It's going to be broken into what we call a write tier versus a read tier. And we have a multitude of configurations. We can do different drive counts. We can do different drive capacities to meet your exact requirements. So if you'll just let one of your StorTrends reps or one of the solutions engineers working with you know what your read and write ratio looks like in your box, we can size that up for you and get you the exact configuration that you need for your infrastructure.
Excellent. Thanks, Justin. And the other question we have here is from James in South Carolina. He says, my company only has about 6 terabytes of data today, but they would like to go ahead and look at all flash storage options. So do you have configurations that are in that capacity range? Yeah,
absolutely. So we support both 200 gig SSDs in the write tier and 240 gig SSDs in the read tier. That's our smallest configuration. It's going to give you somewhere around 4 to 5 terabytes usable, and then with dedupe compression, obviously it'll increase. So yeah, we can absolutely put a 6 terabyte footprint onto this box and still give you overhead to grow into for the next 3 to 5 years as your business grows and your data sets grow.
Excellent, excellent. And Alan from New Jersey, he's asking, do you install and configure the systems that you use for your evaluation and proof of concepts?
Yeah, absolutely. So depending on your location and our availability of our solutions engineers, we'll either come on site. Most of the time we do come on site, or it could be a remote setup, but it's really up to you whether you want us to do on site or remote. We come there, we rack stack the box. It takes about 20 minutes from unboxing it to plugging it in if you have the rack space readily available. It's going to take us about another 20 minutes to configure the box, and then we can start data migration. We'll also spend an extra 45 minutes to an hour with you training you on all of the features and functionality of the box. So we're not just going to ship you a piece of product and say, here's the manual, good luck, and go with it. We're actually going to take time so that you become comfortable with it and you can trust it and you understand how all the features and functions work during that evaluation proof of concept period.
Perfect. And I think we have time for just one more question. And once again, I apologize we can't get through to all of them, but we will go ahead and answer these after the demo. But the last question we have here is from Matt in Michigan, asking how we balance our cost versus our performance and reliability on our unit.
That's a really good question, Matt. That was a major concern in the past, especially spinning disk and hybrid arrays, because you had to understand what do you want from a performance perspective and a reliability perspective, and how much are you willing to give or take versus that cost aspect. So I completely understand your question there. All flash has really changed the game in that regard. Simply because of the performance, you're going to see 250,000 plus IOPS out of this box. So you're not going to really sacrifice a lot of performance no matter what you do to the box, meaning whether you choose a RAID 5, a RAID 10, or RAID 6, you're still going to be 100,000 plus IOPS. So most of our small to medium business, small to medium enterprise customers, they're in that 2,200 IOPS up into about the 13,000 IOPS. That's where most of our customers sit today. So there's plenty of overhead in this box from a performance perspective. So you really don't have to make that choice. Now it's just a determining factor of cost. What is it going to cost me? So you really don't have to think about it the way you did in the past, thanks to the performance that the SSDs have brought, and thanks to the space savings that the dedupe and compression have brought, which allows us to bring that cost point way down. That's a great question, Matt.
Excellent. And once again, I think that's all we have time for this afternoon. Once again, I would like to thank you all so much for attending. We hope you enjoy the presentation, and of course, we hope you enjoy the pizza as well. If you do have any additional questions, feel free to reach out to our team. We should have our contact information posted on your current screen right now. So any questions, whether it be sales-related or technology-related, please don't hesitate to reach out to us, and we will be happy to help. But with that, we'll go ahead and conclude the presentation for today. I hope you all enjoy the rest of your day.
Thank you, guys. You'll have a great day.